In this video, we'll be going over the best time to buy and sell stock 3. So you're given array prices where prices I is the price of a given stock on the ith day. Find the maximum profit you can achieve. You may complete at most 2 transactions. So you may not engage in multiple transactions simultaneously, so you must sell the stock before you buy again. So in our first example, we're given this array of stock prices, and our maximum profit we can get is 6 with a maximum transaction of 2. So we buy on the 4th day, 0, 1, 2, so the 4th day is here, and then we sell at the 6th day. So we get a profit of 3. And then we buy on the 7th day, and then we sell on the 8th day to get 4 minus 1 is 3, so we get another profit of 3, so we get 3 plus 3, and we get 6. Let's go over the thought process. So we have 2 possible states. So the first state is our buy state, where we are allowed to buy the current stock. And then the second state is our sell state, where we are allowed to sell the current stock. Then for each of the stock price at index I, if we are currently at the buy state, we have 2 choices. We can either buy the current stock or skip the current stock. We will want to pick the choice that will give us a higher profit. Now, if we are currently at the sell state, we also have 2 choices. We can either sell the current stock or skip the current stock. And we'll also pick the choice that will give us a higher profit. Now, we should note that we are allowed to make at most 2 transactions. This means we will need to keep track of the number of transactions, which we'll call T, that we have left. After we have buy and then sell, we will decrement T. Now let's go over the pseudocode. So we're going to implement our brute force recursive approach. And then what parameters do we need? We first need I, our current index inside the input array, and also our current states, which we'll call S, our current states. So we have 0 is equal to buy, and then 1 is equal to sell. And then we also have the number of transactions, the number of transactions left, which is equal to 2. Initially is equal to 2. And then we then have our input array, so the input prices array. And then what's the base case? So if I is out of bound, or T is equal to 0, this means we cannot perform any more transactions, so the maximum profit we can get is 0, so we just return 0. Then each of the recursive call, if S is equal to 0, we are allowed to buy the current stock or just skip the current stock. So we're going to recursively find the profit P1 if we buy the current stock. So if you buy the current stock, our index goes to I plus 1, and then our states turn to 1. This is our sell state because we have bought the current stock, so our next state is equal to sell. Our transaction stays the same. And then we're going to recursively find the profit P2 if we skip the current stock. This means we just increment our current index by 1. We just skip the current one. Our state does not change. We're still in the buy state because we skipped the current stock. Then we want to return the maximum value between P1 minus prices I. Basically, we are subtracting the current price because we bought the current stock, so the amount of money we have decreases. And then we return the maximum amount between buying the current stock or just skipping the current stock. we want to return the higher profit. Else, we're currently in the sell state, so we're going to recursively find the profit P1 if we sell the current stock. Sell at the current stock. So I turns to I plus 1, and then S turns to 0. We're going back into a buy state because we're sell at the current stock, so we're allowed to buy again. And then our number of transactions decreases by 1 because we have buy and then sell, so the number of transactions decreases. And then we're going to recursively find the profit P2 if we skip the current stock. Then we can just return the maximum value between P1 plus prices I. Because we sell at the current stock, so we gain the amount of the price of the current stock. That's how much we gain. So, and then we can return the maximum value between selling at the current stock or just skipping the current stock. Now let's go over the time and space complexity. For the time complexity of 2 to the n, where n is the length of the input array, each recursive call has 2 choices and a depth of n. And our space complexity is equal to O of n. This is our recursive call stack memory. Now let's go over the code. So we're going to return. So we're going to implement our recursive approach, keeping track of our current index initially at 0, our current states initially the buy state, and the number of transactions we have left, which initially at most 2, so we start with 2. And our input array, and then we're going to create our recursive method, int I, int s, and then the number of transactions and the input prices. If I is greater or equal to prices.length is out of bound, or t is equal to 0, this means we can no longer perform any more transactions. This means the amount of profit we can get is 0, so we can return 0. Now if s is equal to 0, we're currently in the buy state. We have 2 choices. We can buy the current stock or just skip the current stock. So we want to return the maximum value between buying and the current stock. So I turn to I plus 1, states turn to 1, because we want to move on to the sell state next, and then t stays the same, prices stay the same, and then subtract the current price because we bought it. And then we also need to return the find the maximum profit. We skip the current stock. S stays the same, t stays the same, and our prices array. Else, we're currently in our sell states, so we have 2 choices. We either can sell the current stock or skip the current stock. We want to pick the price, we want to pick the profit, we want to pick the higher profit. So this one is buying at the current, selling at the current stock. So our state turned to 0, which is our buy state, and the number of transactions we have left is decremented by 1. And then we can increment by the price, the current price, and then this one is the amount of profit if we skip the current stock. Okay, we got our TLE error. So this approach is not efficient enough due to overlapping recursive calls. We can avoid overlapping recursive calls using memorization. In the next video, we'll be going over the memorization approach of best time to buy and sell stocks 3. Let me know if you have any questions in the comment section below.